Right, hello students. In today's video, I'm going to show you a very common problem sums that you may see in the textbook, in the test, or even in the exam. This problem sums involve the concepts of bearing, applications of sine rule, trigonometry ratio, and also the concepts of what kind of distance is considered the shortest distance of you or to of a locations to a tree, a house, or things like that. Okay, so let's look at the questions now. So you're given 4 points A, B, C, D on the horizontal view, right? And B is due south of A, right? And C is due east of B. So that will make your angle ABC 90 degrees. Okay, you can refer to this earlier concepts that we've learned. Right, the two lines there, NS and WE, will intersect each other at 90 degrees. Okay, so that's the reason why angle ABC is 90. All right, so the next thing is that we are asked to find the bearing of C from A. So therefore, we will draw the north directions at point A. And the way to measure bearing is you have to measure it in a clockwise direction. Okay, measure in the clockwise direction from the north. Right, so as shown on the screen, we need to find the angle alpha. All right, but before we can find the angle alpha, yes, you will have to find angle BAC first. Right, so since triangle ABC is a right angle triangle, we can apply the concepts of trigonometry ratio. All right, so we can we can label BC as the opposite sides and AC as the hypo, and we can use the sine ratio, right, to find the angle BAC. Right, so sine angle BAC will be 105 over 131. So angle BAC will be sine inverse of the ratio 105 over 131. All right, so your angle BAC will be sine inverse of your ratio 105 over 131, and that will give you 53.28 degrees. We leave it to 2 decimal places because we will be using this answer to find alpha. Right, so therefore alpha would just be 180 degrees minus 53.28, and that gives you 126.72. So therefore your bearing will be 3 digits to 1 decimal place, so that will be 126.7 degrees. Okay, so this part here is relatively easy. Let's look at the next part. Right, so the next part of the questions, you're asked to find the bearings of D from C. All right, so from C, therefore we will have to draw the north directions at point C. And again, we measure the bearings in a clockwise direction from the north direction. So that would be the angle that you're supposed to find, right? Right, and since we've already agreed that angle BAC is 90 degrees, therefore this angle here would also have to be 90 based on the concepts of the interior angle property, right? Both angles add up to be 180, right? And right, so before we can actually find our bearing, meaning find this angle here, we will need to find alpha first, right? However, we do not have enough information to find alpha, but we do have information to find angle BDC, meaning this angle here. We are able to find this angle first using sine rule. Right, so sine angle BDC, sine angle BDC over 105 will be equals to sine 122 over 162. So that is using sine rule. Sine A, if you have forgotten sine rule, please do a recap, do a revision, recap, it's the same thing. So sine A over A equals to sine B over B, right? Okay, So we can do a cross multiply, which is sine angle BAC times 162 will gives you sine 122 times 105. Then you divide both sides by 162. That will give you 0.54966. Then you need to sine inverse that value to give you angle BDC to be 33.34. Then from there, we can find your alpha, which is just 180 minus 33.34 minus 122. So that gives you 24.66 for alpha. So therefore, now we can find the huge angle there, the reflection angle there, which is just 360 minus 90 minus 26.66. And the bearing will be 3-digit, which is 245 to 1 decimal place, 0.3 degrees. Okay, right. So the first two parts are relatively manageable. Okay, the later parts are the one that is a little bit more challenging. Okay, so what happened now is that there's a tower, and this tower is something that is actually sticking up from the ground, right? So this tower will form a 3D diagram with a point ABC, right? So I have a tower that is standing upright on top of point B, right? So the tower is 5 meter. So this is the this one is a tower. So let me label this. This is the tower. I am the tower. I am the tower. All right. And I'm 5 meter high. All right. So you have a gentleman, John. He walks from point D to C, and he stops at point E, and he look up at the top of the tower for whatever reason, I don't know. And the angle of elevation is 6 degrees. And we asked to find the distance BE. Okay. So you just imagine that little dot there, it's John. So he walks along the line BC. DC walks along the line DC. Okay, so he walks and walk and walk, and that is point E. All right, so he look up at the top of the tower, right? So the angle of elevation is 6 degrees. I have a video that I have explained earlier on the concepts of angle of elevations and depression, so you can actually refer to the earlier videos. Right, so we can form a right angle triangle. Yeah, and that's point E, and that angle is 6 degrees. Okay, that is the angle of elevation, is the angle when you spotted something up in the air and you're very happy and you look up. So that's 6 degrees. So we're supposed to find distance BE. So since this is the right angle triangle we're talking about, we can just apply trigo ratio. Yes, so we can use tangent, which is opposite over adjacent. So opposite, it's, oh, I make a mistake here. It's not AB. It's the height of the tower. Okay, so this part here is wrong. It's the height of the tower. I purposely do that because some people may take it as AB. It is not AB because your the tower is at point A. The tower is sticking up. It forms a 3D diagram, whereas your point A is on the ground. All right, so you should not be saying AB. You should be saying the height of the tower to be more accurate. Then over your adjacent, which is BE. All right, so you do a cross multiply. And then you'll find that BE is 47.6 meter. Right, so our dear friend John is at the distance 47.6 meter from point B. Right, so this distance here, this distance here, it's 47.6 meter. And then he look up, saw something at the top of the tower, attracts his attention, and then he formed an angle of elevations of 6 degrees. All right. All right, so now we come to the part when they say it's the most challenging. It's the most challenging because there are certain concepts that we need to understand. John claims that he's nearest to the tower at point E, right? So the questions asked if you agree with him. and we asked to show our working clearly and explain our answer. Right, so the questions you have to ask yourself is, what do you understand by this phrase nearest to the tower? When are you actually nearest to the tower? At what distance are you nearest to the tower? Yes, you are nearest to the tower when you are at the shortest distance from where you are to point B. Right? That means you are the shortest distance referred to the most direct distance, right? So supposing you are there, right? So what kind of distance is the shortest distance? What concepts is involved here when we refer to the shortest distance? What sort of concepts is involved here? Correct. So, sorry, I'm getting a bit excited. So the shortest distance is actually the perpendicular distance. Right. And what we're going to do is that we're going to let the shortest distance be x meter. Yep, that is your shortest distance. We're going to let it be x meter. And we're going to find the values of x. Now, in the earlier parts, we've already found this angle to be 24.66. So we can apply trigo ratio because this is the right angle triangle we're talking about. So if x represents your opposite sides, 105 represent your hypo because it's opposite your 90 degrees. So we can use sine 24.66 equals to x over 105, do a cross multiply, and we found that the shortest distance is supposed to be 43.8 meter. But what was the distance that we calculated for John at point E? Do you remember? If you cannot remember, refer to the earlier slide. Yes, that we calculated it to be 47.6. So therefore, I disagree with John. Why? Because the distance that he got for BE, which is 47.6, is definitely more than my 43.8. Right, so therefore, John is not nearest to the tower at point E. To be nearest to the tower, he has to be at the distance of 43.8. Okay, so this sort of concepts is always tested. Right, so it's good to spend a little bit more time understanding it and practice a little bit more questions on this kind of concept. Right, thank you.